Empirical formulas, note page 94. This will include defining and example 1. So earlier in the school year we defined the empirical formula, which I short form as EF in the notes, as the lowest whole number ratio in which elements combine to form a compound. Through today's lesson, we're going to work through the mathematical steps of going from laboratory data, crunching the numbers, to calculate a substance's empirical formula. So the first step in the process is to convert measured quantities like mass into moles. Once when we have converted each element's measured value into moles, we will then divide each of the calculated mole values by the lowest or smallest mole value in order to determine the mole ratio. We use that mole ratio as the subscripts in the empirical formula. Every once in a while, a calculated mole ratio will end in 0.5. You have one extra step to do to get to the final empirical formula. When this happens, we will simply double the whole ratio to obtain the lowest whole number ratio. Looking at example number 1. Determine the empirical formula if 80.2 grams of calcium reacts with 142.0 grams of chlorine to form a compound. So, first step is to convert each element's mass or measured quantity into moles. Let's take a look at calcium. We have used 80.2 grams in the lab, so we need to convert that grams into moles. So we set up our fractional relationship, which puts moles up top, grams down below, so when we do the math, multiplying all the numbers across the top, dividing by all numbers down below, grams will reduce and we'll end up with the moles of calcium present. So whenever we have a fractional relationship that has moles and grams in it, we have to remember this represents a GFM relationship. And since we are working with elements, we have to simply look at the periodic table to come up with the element's GFM. So go ahead, look up calcium's GFM on your PT. And according to the PT, 1 mole of calcium will equate to 40.1 grams. These are the numbers that we'll use in the fractional relationship. Show your work nice and neat as dimensional analysis. And here we go. We have 80.2 grams times 1 mole divided by 40.1 grams. The units of grams reduce, and we're left only with moles, and this equates to 2.00 moles of calcium. Trying to be very careful to maintain sig figs. Our measured quantity had 3, so when we converted the mass to moles, we recorded the moles with 3. We're going to repeat the steps we did for calcium and convert the 142.0 grams of chlorine now into moles. So we have a very similar setup. 142.0 grams times moles divided by grams. Now we need the GFM relationship for chlorine. Since chlorine is an element, then we'll simply go to the periodic table and look it up. So look on your PT, and according to your periodic table, 1 mole of chlorine equates to 35.5 grams. Use this relationship for the chlorine's fractional relationship. Your work should look like this. 142.0 grams times 1 mole divided by 35.5 grams. So when you put this into your calculator, it works out neatly to a 4.000 moles. Step 1 is done. We converted each element's individual mass into its individual mole quantity. On to step 2. On step 2, we have to divide each of our calculated mole values, as shown up above, by the smaller mole value. So I hope you realize that when you do a quick comparison, 2 moles is less than 4 moles. So we divide both sets both mole values of calcium and chlorine by 2.00 moles. Show your work, keep it nice and neat. Organization goes a long ways. And if you notice in the mathematical setup, both of the calculated moles are being divided by 2.00, and you should notice that the unit of moles in both fractions reduced to 1. At this point, we're left with a unitless number. So when all units reduce to 1, no longer present, this is a ratio, and specifically for us, it's a mole ratio. Mathematically, it works out pretty nice. So we have a mole ratio of 1 to 2. We will use the mole ratio of calcium to chlorine as the subscripts in the empirical formula. So this empirical formula has a ratio of calcium to chlorine is a 1 to 2 relationship. Write the empirical formula with correct elemental symbols and the mole ratio as the subscripts. So our final empirical formula between calcium and chlorine is CaCl2.